We are going to do a complete regression analysis by performing these steps, and I have taken a problem out of your textbook, and this is the problem. It has to do with SAT scores, and it has to do with comparing the verbal SAT score to the mathematical SAT score, and we're trying to see if they are related in a linear way, seeing if there's a linear relationship between these two scores. So the first thing that we do is make a scatter plot. I'm going to show you how to make a scatter plot on your calculator. So what I've done is I've gone to Stat and Enter, and I've put the verbal scores in list 1 and the mathematical scores in list 2. And then to make a scatter plot on your calculator, you touch this second button key, and then the Y equal to, it says stat plot above it. You want to enter in the lower right hand corner, and then you actually want to enter one more time to get that to turn on. And then we want our cursor dark on this type of graph, so come down one click and then enter if it's not dark on that. And then it should say list 1, list 2, because that's where we put our data. And if it says that, if you've got your screen looking like this, then touch this zoom key right here in the middle, zoom, and 9. And your scatter plot should look like that. If you get an error message at this stage, you may have to call me, but sometimes it's because you have stuff in your Y equal to key or other things in your list, or your lists don't match. There's various reasons why you would get an error message right here, but you should be able to see a plot of your data at this point. The next step is to compute the correlation coefficient. The correlation coefficient, we're computing the sample correlation coefficient, and it is an R value. So we're going to come up with an R value, the sample correlation coefficient. Some calculators don't have this turned on right away, so I'm going to show you how to get this to turn on. So it's not going to hurt if you do this even when the diagnostics are on, so I'll just show you how to do it. So you're going to touch second, and then come down to the 0 where the catalog is, and then hold your down arrow and try to get down into the D's. These are alphabetized, so get to D's and get to diagnostics on. You should only have to do this once. After they're on, you shouldn't have to do it again. And then enter, and enter again. It'll say done, then you can just clear that off your screen, and you shouldn't have to do that again. Okay, now touch Stat, arrow right till the cursor's over on Calc, so just one click to the right. There are two linear regressions. One of them is number 4 and the other one is number 8. Your textbook uses number 8. So if you want to stick with what your book is doing, you would choose this one. I'm going to enter on that one. Some of your calculators may look slightly different than mine right here. If yours just says LINREG and like this at the top, you may have to make yours look like you may have to tell it list 1, comma, list 2. And the way you would tell it list 1, comma, list 2 is by touching second and number 1. Here's the comma key. Touch that, then second, number 2, and then enter. Ours is just looks a little different. I've got the L1, L2 here. I don't want anything in the frequency. I'm not going to store this regression equation right yet. So I'm going to come down and calculate. I'm entering. There's the R value I want, 0.9898. I'm going to call it 0.9899 for now. They want us then to test whether this correlation coefficient is significant by testing whether the population correlation coefficient. So a little hypothesis test, it will always look the same. The null hypothesis will be rho equal to 0. That's a Greek letter rho. The alternative will be that rho is not 0. We would really like to reject this, because if you can reject this null hypothesis, that means that there is a linear relationship in the population of SAT scores. So we're going to test it by using table I. I'm going to bring up table I. On table I, the degrees of freedom are n-2, and I believe that we had 6 ordered pairs of data. Let me look at this a second. We did. We had 6 ordered pairs of data. So on here, the n-2, the degrees of freedom are going to be 4. And also, we were using an alpha of 0.1, if I remember right, on this problem. So let me just double check that. Oh no, we're using an alpha of 0.5. Okay, so let me bring that table up again. We're using an alpha of 0.5. So we're in this column by the 4. It's the critical value is 0.811, and we are going to reject rho equal to 0 if the absolute value of r is greater than the value given in the table. So the value given in the table is 0.811. And we're going to reject if the absolute value of r, so we're looking at the absolute value of this number, is more than 0.811, and it clearly is. So we are going to reject the null hypothesis because the absolute value of r was greater than 0.811. And that's good. We want to reject this. When you can reject that rho is equal to 0, you're indicating that there is a linear relationship going on in the population between these two variables. Then they're going to ask you to calculate the regression line. Again, we're going to use our calculator rather than using the formula in the book. So same thing I did before. Stat, arrow right to calc, number 8. I'm coming down to calculate. I should have just left this on my screen where I had it before. It's the same screen where I got the R value a minute ago. This 63.47 is the A that's in this formula, and the B is 0.9. I'm just going to call it 0.9. So I'm going to call this 63.5 and 0.9. This is a strange formula for those of you who are algebra people, because you'll notice that this value right here is your y-intercept, and this value is your slope. Normally in an algebra class that would be reversed. Like in an algebra class, we'd probably write it like this, where the A is the slope. This would be the slope right here, and this would be the y-intercept. It's the reverse of that. Here the A is the y-intercept, the B is the slope. So it's a little bit strange in statistics. But anyway, that's your regression line. They may have you plot it on the scatter plot, and they might have you do some predicting with it, but there's definitely a linear relationship